Soil erosion and hydrological impacts are crucial factors to consider when assessing post-wildfire damage. In this tutorial, we will explore the methods and tools used to assess these impacts and understand their significance in post-wildfire recovery efforts. Soil erosion refers to the process by which soil particles are displaced and transported by natural forces like wind and water. Wildfires can significantly increase the vulnerability of soils to erosion due to the loss of vegetation cover and the alteration of soil properties. Hydrological impacts, on the other hand, encompass all changes in the water cycle that occur as a result of a wildfire. These impacts can include increased runoff, alteration of water quality, changes in infiltration rates, and increased risk of floods and landslides. Several methods can be used to assess soil erosion following a wildfire. Some of the most common techniques are: A. Field observations. Conducting visual assessments of the burned area can help identify signs of soil erosion. Look for evidence of gully sediment deposits or significant topographic changes. B. Sediment traps. Installing sediment traps at strategic locations can capture eroded soil particles. By collecting and measuring the sediment volume over time, you can estimate the amount of erosion occurring in the area. C. Soil loss models. Various computer models and tools are available to estimate soil erosion. These models utilize inputs such as soil properties, vegetation cover, and rainfall data to simulate erosion rates. D. Photogrammetry and remote sensing. Analyzing aerial imagery or satellite data can provide valuable information on changes in the landscape following a wildfire. These techniques can help identify areas prone to erosion and quantify the extent of soil loss. Understanding the hydrological impacts of a wildfire is crucial for managing post-fire water resources effectively. 3 methods to assess these impacts are stream flow monitoring, water quality sampling, and rainfall runoff modeling. Stream flow monitoring. Collecting data on stream flow rates and water quality parameters can provide insights into the impacts of a wildfire on the hydrological system. Monitoring can be done through the use of flow meters, water sampling, or automated monitoring stations. Water quality sampling. Collecting water samples from affected streams can help assess changes in water quality parameters such as turbidity, pH, and nutrient concentrations. Comparing pre- and post-fire samples can provide valuable information on the severity of impacts. Rainfall runoff modeling. Using rainfall and topographic data. Rainfall runoff models can simulate the response of a watershed to precipitation events. These models can help estimate changes in runoff rates, identify areas prone to flooding and assess the impact of the wildfire on the hydrological system. Assessing soil erosion and hydrological impacts is crucial for several reasons. Post-fire restoration. Understanding the extent of erosion and hydrological changes helps land managers prioritize restoration efforts and implement appropriate measures like erosion control structures. And revegetation. Identify sensitive areas. Assessments can help identify areas that are particularly vulnerable to erosion and hydrological impacts. By focusing efforts on these areas, post-fire management can be more effective. Mitigate environmental impacts. Evaluating the severity of erosion and hydrological impacts helps develop strategies to mitigate potential downstream effects, such as sedimentation in rivers or degradation of water resources. Planning and preparedness. Assessments provide valuable data for future planning and preparedness efforts. This information can help communities and land managers anticipate the potential impacts of wildfires and develop strategies to minimize their effects. In conclusion, assessing soil erosion and hydrological impacts is crucial in understanding and managing post-wildfire damage. By utilizing various methods and tools, we can gather data that guides restoration efforts, identifies vulnerable areas, mitigates environmental impacts, and facilitates future planning.